Matrices and Types. Introduction of Matrices Part 2. Objectives. Triangular matrices. Trace of a matrix. Equality of matrices. Multiplication of a matrix with scalar. Upper triangular matrix. A is square matrix A is equal to matrix Aij is said to be upper triangular if Ij is equal to 0 for I is greater than j. Example: matrix 5 minus 4 2 0 3 1 0 0 6. Lower triangular matrix. A square matrix A is equal to matrix Aij is said to be lower triangular if Aij is equal to 0 for I less than j. Example: matrix 1 0 0 1 minus 3 0 0 2 2. Triangular matrix. A square matrix A is said to be triangular matrix A if it is either an upper triangular matrix or a lower triangular matrix. Principal diagonal of a square matrix. In a square matrix, the diagonal for first element of the first row to the last element of the last row is called the principal diagonal of the square matrix. If A equals to matrix Aij is a square matrix of order n, the elements A11, A22 and so on, Ann constitute principal diagonal of A. Trace of matrix. The sum of the elements in the principal diagonal of a square matrix A is called the trace of the matrix. It is denoted by trace of A. If a square matrix A equals to matrix Aij order of n by n, therefore, trace of A equals to A11 plus A22 plus A33 and so on plus Ann, that is, trace of A is equal to summation I is equal to 1 to n Ai. Example: if A equals to minus 3, 1, 6, 7, minus 8, 2, minus 5, 4, 4, then trace of A equals to minus 3 plus of minus 8 plus 4 is equal to minus 7. Trace of A plus B equals to trace A plus trace B. Trace of A minus B is equal to trace A minus trace B. Trace of AB is equal to trace of BA. Trace of KA is equal to K into trace A. Trace of IN equals to I plus and so on up to n terms equals to n. Equality of matrices. Two matrices A and B are said to be equal if A and B are of the same type, order. The corresponding elements of A and B are equal. Example: matrix A is equal to A, B, C, D, E, F and matrix B is equal to 2, 0, 1, minus 1, minus 3, 5 are equal if A equals to 2, B equals to 0, C equals to 1, D equals to minus 1, E equals to minus 3, F equals to 5. Note: inequality never exists between matrices A, B. That is, statements like A is greater than B or B is greater than A are meaningless. Multiplication of a matrix by a scalar. If every element of a matrix A is multiplied by a scalar k, real or complex, the matrix obtained is k times the matrix A. That is, if A is equal to matrix Ij, order of m by n, then Ka is equal to matrix Kaij, order of m by n. Example, A equals to matrix 2, 6, 3, 5, 9, 1, 7, 4, then Ka is equal to matrix 2k, 6k, 3k, 5k, 9k, k, 7k, 4k. Note, minus 1 of A is equal to minus A, and minus A is called the negative of the matrix A. Also, minus of minus A is equal to A.